Well, hi, hello, my dear students. Welcome to my video lecture class. Right up to now, I uploaded video lectures on the topic Newton's laws of motion and friction. In this topic, friction, I already explained what is meant by friction, how many types of friction we had, what are the laws of friction, what are the factors affecting on friction. So these are all things I discussed in the previous lectures. Please go to the previous lectures for better understanding. Today I would like to discuss the very important topic in friction. So friction topic should contain some applications. These applications are very useful for solving numericals in JEE and NEET. So now I am going to solve few problems based upon this friction topic. Before going to solving numericals, I'll explain few applications on friction. Please observe the lecture carefully and watch the lecture till the end. So definitely you realize that you should love the subject physics. So please watch the lecture till the end, right? So now, first of all, frictional force, full form, frictional force versus pulling force diagram. Frictional force versus pulling force diagram. So now here frictional force is frictional force. Frictional force is represented in y-axis. Next, pulling force. Pulling force. Pulling force F is represented in x-axis. How can we represent it in diagram? So this is, here is represented in like this. Here is the here from this point O to here in this point, so we are taken as state of rest. This is called state of rest. This is called state of rest. This line is called static friction. This is called static friction. Static friction. Here in this, dynamic friction. Dynamic friction. Here, this is state of motion. State of motion. Okay, so this is state of rest, this is static friction, this is dynamic friction, this is state of motion. So this is about frictional force versus pulling force diagram. Observe carefully one by one here. Initially the body at a state of rest. Initially body at state of rest. That means applied force is less than the frictional force. Applied force is equal to frictional force. How much frictional force is there? How much frictional force is the same amount of force is applied. If frictional force is equal to applied force, then body is in state of rest. So up to here in this point, the body is in state of rest. After some time, what will happen? It should be in state of motion. At the state of rest, a body has some friction. That friction is called static friction. This is called static friction. After some time, applied force is increases. Then definitely body is in motion. observe carefully. If F is equal to Fs, the body is at rest. If F greater than Fs, the body is in motion. So body is in motion. Definitely body is in motion. Applied force is greater than frictional force. The body is in motion. Whenever body is in a motion, the frictional force developed on the body is called dynamic friction or kinetic friction. This is kinetic friction. So this is nothing but state of motion. Okay. So this is about overall diagram explanation. Next, I am going to discuss application number 1 based upon friction. So before going to explain application number 1, small topic, angle of friction. Angle of friction. So this is very important topic. What is meant by angle of friction? First of all, we'll discuss definition. So what is the definition? The angle made by resultant of frictional force F and normal force N with the normal reaction N is called angle of friction. Okay, so is called angle of friction. So here I draw the diagram. Here the surface is rough surface. I place one block on this rough surface. Okay, so here friction force, normal force is acting upward direction, perpendicular to surface always. Frictional force is acting in this direction, and here this is a resultant force. Resultant force is acting in this direction, normal force is acting upward direction, frictional force is acting this direction. Here this is angle, pi. Here pi is equal to angle of friction. Pi is equal to angle of friction. So now observe definition. Angle made by resultant of F and N. This is resultant or not? Resultant of F and N is Fr. So Fr, angle made by resultant of F and N is Fr. That Fr made an angle with normal reaction. So this angle is called angle of friction. So this angle of friction, here observe carefully from this tan pi is equal to. See here in this diagram, observe carefully. So this is a resultant. This is a resultant force. This is a resultant force, and this is a normal force. This is normal force. This is resultant force. Definitely, this is not what? This is frictional force. Here is angle pi. From this tan pi is equal to opposite side by this opposite side by adjacent side, that is n. From this F by n, F is equal to mu s into n. Already we know frictional force formula, mu s into n by n. Here n going to be cancelled, that is equal to mu s. Tan pi is equal to mu s. Pi is equal to tan inverse of mu s. Pi is equal to tan inverse of mu s. That is a angle of friction angle of friction pi is equal to tan inverse of mu x. Tan inverse of mu x. So this is very important. Angle of friction pi is equal to tan inverse of mu x. Here mu s is coefficient of static friction. Coefficient of static friction. Coefficient of static friction. Coefficient of static friction. Mu s is coefficient of static friction. Next. Angle of friction is finished. In this angle of friction, pi is equal to tan inverse of mu s. If I consider here the body is in motion, then frictional force is developed, frictional force is developed, frictional force is developed between block and surface is called kinetic friction. Kinetic friction F. Block is in motion. Whether block is in motion, then definitely what is here? Definitely tan pi is equal to mu k. Whether block is in motion, the body is in motion, definitely tan pi is equal to mu k. Tan pi is equal to mu k. So from this, tan pi is equal to mu k. Here, so already you know this is a resultant force. This is a normal force. Here it is a frictional force. This is a resultant force. Resultant force. Is it or not? So here is angle pi. From this right angle triangle, FR square is equal to F square plus N square. So resultant force FR is equal to square root of F square plus N square. So from this, mu into N whole square plus N square. Mu into N whole square plus N square. From this, mu square. Here we take N square. Mu square plus 1 taken root. Here resultant force Fr is equal to, here N is taken out, then finally we got mu square plus 1. Mu square plus 1. Already you know Fr is equal to N into mu means tan pi or not. Mu is equal to tan pi whole square plus 1. So that means N is N into square root of tan square pi plus 1. That is equal to N into secant pi. So because according to trigonometry, secant square pi minus tan square pi is equal to 1. According to trigonometric identities, secant square pi minus tan square pi is equal to 1. So here secant square pi is equal to 1 plus tan square pi. Then secant pi is equal to square root of 1 plus tan square pi. So from this here we got secant pi is equal to square root of 1 plus tan square pi. So here finally we got Fr is equal to N into secant pi. Here from this diagram, here already you know this diagram. So initially I draw one diagram. From this diagram, this is a normal force N. This is a mg, weight mg act like this. So from this n is equal to mg or not? So normal force n is equal to mg. So substitute here. In normal force n is equal to mg into secant pi. So resultant force Fr is equal to, the resultant force Fr is equal to mg secant pi. So this is a resultant force acts on a block whether the block is in motion. So this is about today's session. In this session I discussed diagram. So what is the diagram? Frictional force versus pulling force diagram, explained clearly. Next, angle of friction. What is meant by angle of friction and how we taken angle of friction based upon diagram, and how to derive the angle of friction. What is the formula of angle of friction? Okay, whether the body is in motion, angle of friction tan pi is equal to mu k. So whether body is in motion, kinetic friction is acting. So from that, next we are calculating resultant force Fr, resultant force we are calculated. The resultant force Fr is equal to the resultant force we derive resultant force, that is equal to mg secant pi. So this is about overall session. Next lecture I am going to discuss few application on this friction topic. So I hope you all are understood this lecture. Regarding this lecture, if you will get any doubt, please mention in comment box. So again I'll come back with the new concepts and new formulas. So please watch my lectures. Definitely you must enjoy these lectures. So thank you for encouraging me. Thank you so much.